fell from the top of a cliff into the ocean. In the air, it had an average speed of 16 meters per second. In the water, it had an average speed of 3 meters per second before hitting the seabed. The total distance from the top of the cliff to the seabed is 127 meters. And the stone's entire fall took 12 seconds. How long did the stone fall in the air, and how long did it fall in the water? And then it gives us a little thing. The stone fell in the air for blank seconds, and it fell in the water for blank seconds. So when we're doing word problems, our first thing to figure out is, what do we want to use for our variables, and what do they stand for? So we know that this is going to be a system of equations, so we're going to have two variables, and let's just say it's x and y. And what we're going to say for this particular problem is that this is going to be x, all right? It's going to be how long it fell in the air. And then we're going to say that the time for it's in water happened to be y seconds. So it's falling in the air for x seconds, and it's falling in the water for y seconds. Well, if we look back at the problem, we can kind of see how all those other pieces of information fit when using these variables. For instance, let's use the very last part. It says the stone's entire fall took 12 seconds. Well, that means however long it fell in the air, and plus however long it fell in the water, its total time in falling from the top of the cliff to the bottom of the water, or the bottom, is going to be 12. All right? So that's our first equation. Now, the next equation is a little bit different, and you've got to kind of think back into probably what you did last year in science. There was something that was called the distance formula. And the distance formula has something to do, is if, I'm going to paraphrase, is if you know how fast something is traveling, its actual speed, if you take its speed and you multiply that speed by the time that you're traveling, okay, you'll get the distance. For instance, let's pretend that I am traveling 60 miles per hour, but I ride for 2 hours. So 60 miles per hour for 2 hours. What that means is I have traveled 120 miles. All right? Let's do the same thing. Instead of doing 60 miles per hour for 2 hours, let's say that I am traveling for 3 hours. Well, that means that 60 times 3 would give me 180 miles. Okay? Now let's say that I traveled 60 miles per hour for X hours. Well, how far I actually traveled is 60 times X, or 60 X miles. Now this really sounds weird because it says it's a 60X, but that is a number. It is an expression. I traveled for 60X miles. So using this information, we can do something very similar. Let's see. I am going to do something here. Sorry. Copy and clear this out. All right. There we go. So, using that information, we can put our original equation back. All right. We can actually calculate how far it fell in the air. All right. So, in the air, it had an average speed of 16 meters per second. So, if we take that 16, all right, and we multiply it by that x, this expression that I just wrote is telling me how far it fell in the air. That's the actual distance it fell. All right? Now, we can do the same thing for how long it fell in the water. In the water, it traveled for 3 meters per second, but it traveled for y. So what we found out is that this means that it actually traveled 3y meters while in the water. So what does this mean for us now? If we knew it traveled 16x meters in the air and 3y meters in the water, we can add those two things together, and what we will get is a total of 127 meters. So let me show you this in a picture. It might help out. So here's my cliff. Here's the water, okay, my water, and I am dropping a stone. Well, that stone falls. And what it fell at a speed of 16 meters per second, but that distance that it fell from here to here is 16x. All right? When it hit the water, that stone that was right here started to slow down. And it slowed down to 3 meters per second. But that distance that it traveled from here, from the top of the water, or from right here to the bottom of the seabed, happens to be 3y. All right? That's where this distance is coming from. But we also know this, that the entire length from cliff to seabed, from the cliff all the way down to seabed, happens to be the 127. So knowing those things, we made that equation, 16x plus 3y equals 27. All right, so I am going to see if I can make a copy of this real quick again and clear that out. We'll put it back. And so here were our equations. Our first equation happened to be x plus y equals 12. My next equation that we came up with was 16x plus 3y equals 127. Now what we've got to do is we need to use the substitution method to solve. And the best way to do that is by taking this first equation, x plus y equals 12, and let's solve for y. What we'll do is we'll subtract x from both sides, and we find out that we can rewrite this first equation as y equals 12 take away x. And now that I know what that first equation can be written as, we can actually do substitution. I am going to substitute this expression in the place of my y. Now, when I do that, I get a new equation, all right? I get 16x plus 3 times that expression, 12 minus x, equals 127. Now, when we have that, our next step is to go ahead and do the distributive property. And when we do the distributive property, it simplifies this side to 16x plus 3 times 12 is 36, and 3 times a minus x is minus 3x, equals 127. We're going to take these terms that are alike and combine them. So we are going to combine like terms 6x and the minus 3x. And what we get is 13x plus 36 equals 127. Our next job is to subtract 36 from both sides. When we do, we get that 127 minus 36 is 91. So I get 13x is equal to 91. And last, I divide by 13 on both sides. All right. This cancels out, and I get that, I'll bring this up here, x is equal to 7. So what we found out was that the x, being 7, that x was what we determined earlier, happened to be how long they fell in the air. So the stone fell 7 seconds in the air. Well, if we know how long it fell in the air, we also need to find out how long it fell in the water. Well, remember, back at the very beginning, we determined that it took a total of 12 seconds. So we can plug 7 in the place of our x, or simply solve, and we realize this, that our y is going to be 5 seconds. So it was 5 seconds in the water. And I'm lazy, and I'm going to write H2O. All right. So this one required a lot of brain power because, one, you had to kind of think back a little bit of science from last year about how your distance formula calculated, and then how to combine everything. So ultimately, 7 seconds, it was in the air for 7 seconds, and it was in the water for 5 seconds before it actually hit bottom.